I'll try and give you a quick view of what Siemens has been pursuing in this area of the digital thread and how we see that impacting the industry, the machinery industry of tomorrow as such as well. So from our perspective, when we look at digitalization, what we're really trying to help companies do is make this digital thread that's been spoken about as something that can enable a company to explore new business opportunities. The whole idea of transforming how you run your business is becoming more and more relevant and more important today. We heard a lot of discussions even this morning about how disruptive transformations are happening. So every company is now trying to figure out, okay, what can I do differently to serve my customer? What can I do differently to provide a different service, a different way, so that they are more aligned to what I can provide and they'll be more attached to me. So that's the whole notion of a different business model, and to enable that different business model is where the digitalization process comes in, where you are trying to now look at your entire company's process from the start of the design process, from the start of you thinking about the innovation, all the way to how the customer is going to be using the machine or the equipment itself. So when we think of the whole digitalization process, we are looking at the start of that process when you are thinking of the idea of the machine, the product that you will be building. How are you going to design and build that product? And typically what happens, in fact, what I've been hearing since morning is a lot of the presenters talking about the whole IoT and the utilization of that data. Right? How do you capture that data when the product is being used, the machine is being used, you're getting the information from your machine, and you're feeding that back into your design process or into your manufacturing process. One of the areas where we think this process is missing, at least some of the thoughts that are missing, is how do you actually realize and you actually manufacture your machine itself. So this is where we are trying to take a complete, holistic view of the entire digitalization process across a company, from the time they start thinking about the product, from the time they put a concept about the machine, to the time they actually start manufacturing it on the shop floor, to the time they actually deliver it to the customer, service the machine, and then feed that data back into your design engineering process. So to us, this is the whole view of digitalization, where you're trying to take advantage of this digital knowledge throughout the life cycle of your product. So when we start looking at this a little bit more closely, one of the things we think is very important is to have a very rich data model which can represent your product. This rich data model is going to make it easy for you to enable your different business processes that you're trying to look at. And this rich data model is actually going to help you blend that virtual world, the digital world, and that physical world. When you are able to bring those two worlds together, Sal actually, if you remember, the first slide he had was the engineering slide and the manufacturing slide, and how they're separated and disparate in most cases today. So what we are proposing is this rich data model, which will help you all the way from a design process, through your manufacturing process, and through your service process, which will expand and which will enable you to capture all that knowledge about your product itself. So you can start extracting valuable information from your product information and then start using that to derive new business processes. So this will help you obviously in your initial product design, all the way from requirements to planning your work instructions, enabling your configuration, and then all the way through production and then the service itself. So I'm going to try and keep this a little bit faster in the interest of time here right now. And use this maybe to give you a simple example, right? So as you start capturing more and more of your service data, before you actually start capturing your service data, you have to think about how are you going to design that machine so you can get maximum value out of that service data as well. That whole sensor data that you're trying to capture, you just cannot plop another temperature sensor at certain point. You cannot just plop another vibration sensor at a spindle, which may be actually a good example, but you actually redesign your entire machine itself. So that's where, with the addition amount of sensors and controls that you would be adding into your machine, you need to rethink even the way you design and machine and manufacture your machine itself. So that's where we have the whole notion of a mechatronic-based design process, where instead of doing a serial process where you have a mechanical, electrical, and automation software design, you have this whole joint mechatronic system-based design process, which makes it a lot more easier and efficient to design your entire product in this unified manner. The second is being able to virtually simulate and evaluate the behavior of your machine. Now this becomes a very, very important factor because you are now going to be adding a lot of new controls and sensors into your equipment. So how do you make sure all of that is going to work in an efficient manner without actually building that physical machine? So that's where the whole notion of virtual commissioning comes into picture, where you can virtually simulate the entire behavior of your machine without actually building any physical part. This is a very important investment we think companies need to look at, and actually it's also another key area for us where we are putting in significant effort to deliver that virtual commissioning capability, where customers can actually design a build and test and evaluate the entire machine without actually building any physical prototypes. Then obviously the whole notion of intelligent production, which will be driven by the way you have designed and configured your machine so that it can drive the production process itself, knowing the exact configuration based on one specific customer need and driving that whole production process, being able to even do the subsequent analysis on the machine when it is in the field, being able to do updates on the machine if there is a need to do any updates on the software. And this is where we have the whole notion of two-speed updates, where you are now needing to update the machine automation maybe at a different cycle than the rest of your development cycle in-house. So this is where you'll need to have the ability to do updates on your equipment in a different format, in a different scale, if you will, compared to the scale and the speed you're running in-house, and then being able to drill and isolate the issues that you may be having on your machine as well. And then while you have got all these issues figured out, if required, having the ability to 3D print that part. This is where now things get even more interesting and more dynamic. Now where instead of you supplying that part to your customer, your business model may be changing. Now you may be actually be providing that customer with a 3D model. So instead of supplying them a part, you will be in the business of selling them a 3D model, which they will print on their premises on their own. And now all of a sudden, instead of them buying a physical part from you, they'll be buying an electronic file, number one. And number two, because they are providing you a lot of analytics and a lot of data, a discussion that actually happened earlier, not only will they be a customer, they'll be a supplier to you. Because now you're getting information from them that you are using, rich information from them, to improve the quality of your product itself. So they are a supplier to you. So this is where business models will be changing. This is where we see things turning around in the way your relationships with your customers change and how you can be trying to improve the way you do your business. Now, another big important thing is this whole notion of the digital twin. Bob mentioned it earlier. And this is where, as a company, we are investing significantly. If you look at how models have been created in the past, you had the paper models and some physical testing, which moved to a 3D model and some simulation and testing. What we are trying to do now is make that even richer, where you can evaluate the system behavior on that digital model, and you can evaluate the system performance or that machine performance on that digital model itself. So this is going to become more and more critical as you start trying to build more configurations of your machines, offer more options to your customers. You will not have the ability to build as many physical prototypes, so you will need the ability to digitally evaluate the performance of your equipment. So this is where the digital twin also comes into picture, which will also help you define the operating boundaries of your equipment. Right? There was an example given by one of the gentlemen in the earlier session where they spoke about the operating condition for the drill was around 2 Gs and it was being operated in 10 Gs. Now, how did you figure out the 2 G is the ideal operating condition? So that's something that you can evaluate using a digital twin and identify and set those parameters. And this is going to become more and more critical in terms of how you will be able to design and define your machines itself. And this is an example of how we are enabling the blending of the digital twin with the physical world, right? So now we can, here's an example of a company we have worked with quite closely, Capniles. They make grinding machines. And what they are doing now, using the digital twin, they can fully commission a machine without actually building a physical part at all. They have saved close to 30% of the time, the delivery time. So before they actually start cutting even a single piece of metal, they have fully evaluated the function, the control, the behavior of the machine. And once they have got that all of that tested, then they actually start building the actual physical machine. So what we are trying to say is as companies look at new forces that will be requiring them to change the way they do things, you'll need to think about how to do things like crowdsourcing, how to get more and more people involved in your design process, the whole systems thinking, which is going to become more and more critical, right? The whole mechatronic-based systems thinking, so that you can evaluate the performance of your equipment at one life cycle itself. Having the ability to do life cycle analytics as the equipment is being used, as the machine is being used, having the ability to feed that information back into your design process. And then even changing the way the products are machined and designed and built, right? The whole notion of additive and hybrid machining. The advanced robotics, there were some examples given earlier in the morning about human-robot interaction working simultaneously together. And then the whole idea of intelligent automation, which can drive not only the automation process, but being able to control that with the actual original machine design itself. So Siemens is obviously putting a lot of effort into it. This is, from a Siebel's global perspective, this is one of the 3 corporate initiatives in the company and outside as well that we are enabling our customers with, focusing both on the product lifecycle management, on the MES for the manufacturing systems, and even on the automation requirements for customers. And from a use perspective, while we are obviously trying to enable other companies, other customers, we are also using this in-house. Siemens is also a manufacturing company. We make equipment, we make PLCs, we make controls. This is an example of one of our factories in Hamburg, where we make more than 10,000 different product variants for potentially around 60,000 customers today. At any point in time, we are making, in a month, more than 1 million products. That's one product a second that's coming out of this factory in Hamburg. And then there's a whole bunch of product items that get processed through our systems there, and then the amounts of defects and quality. So this is our own internal use and adoption of our own digitalization strategy that we have obviously taken advantage of ourselves as well. So with that, Sal, thank you so much for your time, and I guess we'll be around for some more Q&A now, right? So thank you.